The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Depending on where you're logging in from, one of those will sound just about right. Welcome back to another great episode of our Best Practices webinar series with SevenSignal. A lot of you have logged on early. Thank you for doing that. If you'd like to, please let us know where you're joining from. If you are working remotely today from home, if you're in the office, as you can see, I am back in the Cleveland headquarters office, and we are joined by Jim Vada and Dave Hallis today. How are you guys today?
I'm doing great.
I'm doing great too.
Great to hear, Jim. Great to hear, Dave. And Jim is joining us from Cincinnati, and Dave is joining us from Kent, Ohio. Did I get that right, Dave?
That's correct. I'm just a little bit away from the Dick Stadium.
Perfect. All right. I see a lot of you dropping in here. We have Jasmine joining us from Montreal. Thank you, Jasmine, for joining us. Let's see here. We have Chris joining us from Texas. Thank you, Chris, for joining us today. Really appreciate it. We have Peter joining us from Boston, where it's in the high 40s today, a touch of spring weather. Great, Peter. We're enjoying that here as well. And we also have Kenneth joining us from Denmark again. Thank you, Kenneth, for logging in today. All right, and with that, we will go ahead and move forward here. So we are SevenSignal, the leader in wireless experience monitoring, and we'll tell you a little bit more about our story as we move forward. So we have a great topic here today, backed by popular demand with Dave Hallis, causes and symptoms of high channel utilization. And as I mentioned, we also have Jim Vada here, our Chief Wireless Officer, to join us and to assist with the Q&A. And I'm Kelsey Rizzuto, the Marketing Specialist here at SevenSignal. And we're really excited to dive in today and hear from the audience. A couple of announcements before we begin. First off, thank you to everyone who attended our virtual user group last week. Loved connecting with you all last Wednesday, and we're really excited and gearing up for the exciting year ahead of us for 2021. As always, we also partner with CWNP for every single one of our webinars. So if you are pursuing a certification and would like CE credits for attending today's broadcast, just drop us a note and we can send that over via a PDF certificate per request. Also, another announcement, congratulations to our newest SevenSignal certified wireless engineers. We have David Oliver, Jel Truyers, and Jaron Jose. And I apologize if I botched anyone's name there, but congratulations to you three. Really great news to hear that. We also post a product tour every single Friday at go.sevensignal.com/tour. So we'll go ahead and drop the registration link in here as well if you would care to register for this week's webinar. We post all of our slides to our Twitter account after the broadcast, so go ahead and give us a follow at SevenSignal. But if you aren't on Twitter, you'll all still receive a follow-up email tomorrow with today's presentation slides and the recording as well, so you'll still be able to access that. We additionally post our recordings to our YouTube channel, so look us up at SevenSignal as well. And all of our archived webinars are there too. So go ahead and rewatch some of your favorite topics we've covered in the past and stay tuned for more postings there. And last announcement here, as we've mentioned on previous webinars, stay tuned. Soon we will be announcing who is the winner of our February giveaway of an Oculus 2. Very exciting news here. So we'll be giving away an Oculus to a lucky winner who's attended some of our webinars over the past month. So stay tuned for that.
Hey, how did we get in for that?
Dave's going to be joining every webinar in the future just to get that chance. Another announcement here, we also have a really exciting webinar coming up on March 31st, where we will be joined by special guest Jeremy White, executive editor at Wired. And on this webinar, we will be diving into how the post-pandemic will change remote working. So stay tuned for that, and we'll also drop a registration link here in the chat as well if you want to register early. A little background on SevenSignal before we begin. We were established in 2007 in Helsinki, Finland. We're now located in Cleveland, Ohio. We've hit a lot of major milestones in our history that we're really proud of, such as our 1 billion data points that we're analyzing daily, in addition to 5 million devices monitored daily as well. We also have 14 patents and climbing. So the technology you see from SevenSignal, you are only going to see from SevenSignal. A little background as to what makes us so different. If you look at your typical enterprise LAN infrastructure here on the right, you've got great tools already installed on the network, giving you really useful feedback and data, such as your Cisco, Aruba, and more. But what we do is we pick up where they leave off, moving into a different space with Mobileye. Mobileye lives on the individual devices, monitoring the network from the edge, and gives you full visibility into the user experience. So Mobileye can ultimately be installed on any mobile device, such as your mobile phones, your pickers and scanners, workstation on wheels, your laptops, and more. And it can be installed on any Mac OS, Linux, Android, or Windows device as well. And what's great also about this is Mobileye gives you the full visibility into your external home networks as well. A lot of us are working remotely today, and it's still mission critical for us to stay connected to our work. So we can give you that perspective as well into your users' remote networks. Additionally, we have Sapphire Eye, which are the sensors for service level quality and RF visibility. And through this combination, you're really getting a perspective into the network that you just can't find anywhere else. All right, one trivia question here today before we pass it over to Dave. Great question. We're going to see how you all answer this. Dave and Jim, can you see this question up here?
I can.
Perfect.
Yep.
Okay. You know you're a Wi-Fi nerd when your home SSID contains emojis, you argue with people about using Wi-Fi version numbers or IEEE 802.11 amendment names, you know the first 3 files supported by the original IEEE 802.11 standard, and you like to use them as small talk at parties, or all of the above.
Dave, I feel personally attacked by this trivia question.
Well, don't we all? It just kind of shows that we're all.
They all apply, unfortunately.
All right, let's see how we did here. Dave, what do you think about this?
What the? People didn't get the all of the above. So I'm severely disappointed. Because you can use emojis in some your SSIDs. We actually test for that in Mobileye.
Right.
That's why you know that you're a real Wi-Fi nerd.
Awesome. Well, thank you to all of you for answering that question. We're going to go ahead and get started here, and I will pass the controls over to Dave so he can begin this presentation.
So, okay. Jim and Kelsey, let me know if you're able to see my screen.
Yes.
Looks good.
Cool. Some quick stuff about myself. Solutions engineer here at SevenSignal, CWNA certified. Lots of experience in wireless. At Cisco, I was recognized as a Cisco innovator. I was also kind of known from being involved with IEEE 802.11 standards and Wi-Fi Alliance. That the chaired 802.11i, which was enhanced security, which was WPA, WPA2. Also chaired, I was the original task group chair for 802.11h, which was for sub 1 gigahertz operation. And then I was also involved in the beginning formation of the Wi-Fi Alliance. And then I've got a number of patents. So I was going to change things around a little bit and talk about the symptoms first about high channel utilization. So it's, why would you actually care? If you've got high channel utilization, what a user is going to end up seeing is, like, you can see reduced throughput, increased packet loss, or increased jitter. So when we're doing our voice tests, you'd end up seeing that impact. Also, as channel utilization gets larger and larger, you could end up seeing wireless disconnects. And then in extreme conditions that you can't even access the wireless. So, somebody's just saying, hey, Wi-Fi doesn't work. And so that's why that at SevenSignal, this is really important to us. And we take a look at channel utilization a lot. So next, we'll kind of get into what are the causes. So the first thing is most people have kind of do a channel plan. If most of your APs are using the same channel, you may have high channel utilization. So this is something where, I'm not saying that if you do this that you're absolutely going to have high channel utilization, but obviously in this extreme example here where we kind of show that bunch of the access points on the same channel, for instance, using channel 1. Yeah, everybody on that channel, obviously that's wireless is a shared medium. It's going to boost that high channel utilization. That's going to be an issue for you. There's another one that a lot of people kind of come up with. They kind of see it as something that, oh, this looks interesting. Let's do that. If you have a large number of SSIDs, you may have high channel utilization. Here I'm showing an extreme example where we're kind of showing, hey, there's 10 networks that are basically 10 SSIDs all on that same channel because they're coming out of the same access point. There's like 10 SSIDs. You're asking for trouble there. So you should really try to try to get yourself down around 3. Now, there might be reasons why you have a number of SSIDs. For instance, it's common to have like a guest network besides the corporate. There's a lot of times there's a BYOD type of SSID. But sometimes companies, especially if you're a large company that's doing acquisitions, you're supporting like old SSIDs and new SSIDs. So you might have to live with it for a while, but you should always kind of think about it and say, hey, can we consolidate these? A lot of times too, it might be just from a practical perspective, you say, hey, I need to limit the amount of traffic. For instance, if you've got some of these barcode scanners, you might say, well, I've got this SSID and the devices themselves only support some very limited type of security. You might want to put them on a network that is very isolated. That's understandable. But you just need to kind of keep that in mind, is that you are causing the high channel utilization to kind of go up. So you might want to take a look at that and say, do you really need it? Can you consolidate these things? If you're using wider channels in, for instance, 40 megahertz and 2.4, you may have high channel utilization. So I won't get into this too much details. I'll just kind of bring up some of the acronyms. There's something called the NAV. So when a client is trying to transmit, if you're on channel 1, those devices will see that there's a 40 megahertz wide channel. But the clients that are on channel 6, they're not going to be able to set their NAV correctly. I know that's a bit of a bit of detail. It just has to do with the way that wireless does the collision avoidance. There's a sort of like a pseudo energy detect or signal detect, and it's even when you're not detecting, if you're able to see the beginning of the transmission, that the device will know to hold off for a while. But since that's not on the channel, it's not able to do that. So this is going to cause higher retries and higher channel utilization. Just like inside of the 2.4, you don't want to have 40 megahertz wide channels. If you're on 5 gigahertz and you're using 160 megahertz wide channels, you may have high channel utilization. Something that I know we've talked about in the past is that there's very limited space in the 5 gigahertz range. And I know I was watching a fantastic webinar by Jim talking about the 6 gigahertz space. That's really where you want to start to go if you're kind of going into it. Even in the 6 gigahertz, you really want to think about that twice as far as using 160 megahertz wide channels. A lot of times I've heard of people talking about when we're getting into 6 gigahertz, kind of like being the 80 megahertz being the new 40. Likewise, if you're in 2.4 gigahertz, if you are using channels besides 1, 6, and 11, you may have high channel utilization. This kind of gets into that same type of thing of you're going and you're interacting. You're on the same channels actually as that 6 and 11 if you're on something like 7. And likewise, you're even making it worse because of that nav issue that I talked about. That's if somebody's actually on channel 6 and there's another device on channel 7, they're not able to set their nav correctly. Now, I know it's a little bit of a detail, but it's something that's, will cause issues for you. Another thing is if you have a constant interference source, you may have high channel utilization. You got something that's just sitting there on channel 6, just transmitting constantly. Yeah, it's going to be something that's going to cause you some issues, whether that's interference and collisions, but also your channel utilization is going to go up and cause you some problems. Here's something else that kind of look at a lot at SevenSignal. If you have a large number of APs in an open area, you may have high channel utilizations. And so this is something that arenas will struggle with a lot, and that we usually try to come in and help out. There's a number of things you kind of do there. Libraries, outdoor venues, they're all going to be running into this issue where if you just kind of saturate the area with a bunch of APs and have them running, they're all going to be able to hear each other because of the line of sight, typically in an outdoor venue. Or the same thing applies in arenas and like in libraries where it's very open. That if you're in like an office space, you do have the walls and so forth that actually kind of help you limit the amount of signal that gets to different areas. But when it's wide open like that, and that they start adding a lot of access points to kind of help with because there's going to be a large number of clients, for instance, and obviously in an arena, that you're going to see a large number of clients. They added a lot of access points, but they're actually kind of making things worse. You really need to look and say, well, how can we address that issue? Obviously, in arenas, that would be something that typically you'd be looking at directional antennas to help you out. Then also most vendors do provide a feature kind of to limit the probe responses so that you don't have that overhead of the probe responses actually eating up a large portion of your channel utilization. So if you have a large number of APs in an open area, you may have high channel utilization. If you're supporting older devices, you may have high channel utilization. This one just kind of showing that there's a device. Well, what is this graph actually showing? It's just showing that there's one device and 100% of its transmissions are actually going out at 1 megabit per second. What's the problem with it? Well, the problem with it is that when you're running at a lower data rate, you're on the air a significantly larger portion of the time. So therefore, that increases that high channel utilization because of that older device. So if you do have some older devices that are running at these lower data rates, then you want to take a look at it and say, hey, can you get rid of them? Because you might think about it, it's like, well, it's just that device, that maybe it's not operating at its peak performance. That's actually incorrect because it's impacting all of your other devices. So if you had one old device and 100 new ones, that 100 new ones, they're all being impacted by that slow device. You really want to take a look at that and see if you're able to kind of either replace it, upgrade it. Also that there's the basic rates, by removing the basic rates so that the access points aren't sending those beacons out at those low data rates. That'll help you out and to make it so that your channel utilization isn't so high. Kind of got through them all real quick. Kelsey, Jim, I know that there's a number of topics in there.
Yeah, thanks, Dave. And I think kind of putting it all together, I think for me it helps to really focus on the channel part of channel utilization, and what we're really optimizing is our use of the spectrum. So just like you cannot, you might not have enough APs to provide the capacity you need. you can have too many APs that provide reduced capacity. And the reason is because there's only so much spectrum we have. There's only so many channels we can use. And when we add more APs than there are available channels, well, we have to start stacking them all up on the same channel, like the open area arena use case. That's unavoidable. There's only so many channels, and they have to start putting APs on the same channel. But when we do that, if those APs are close to each other, we're actually not increasing our overall capacity because the channel is still the bottleneck if the APs are nearby. And actually, it gets worse because, like Dave said, the APs each transmit their own beacon frames for every SSID they support 10 times a second. So when we're adding another AP to the same channel, we're adding more beacon traffic that uses a low data rate and chews up airtime, which increases channel utilization even when the network is idle. So it's a very careful balance, right? We have to strike between, particularly when we're considering delivering as much capacity as possible, between adding APs and reusing channels and trying to keep the channel utilization, within an acceptable bound. And of course, trimming data rates is an important part of that too. So Dave, we've got a few good questions here. Start out here with one from Forrest, and thanks for the question, Forrest. He says, if you have several SSIDs but they're not in use, and only one is being used by clients, do the unused SSIDs still flood the air with beacons?
Yeah, good question. The answer to that is yes. That you will see that if you were just do a packet capture, what you would end up seeing is even if there's no clients, you will see that there are beacons going out. And as Jim kind of mentioned, if say for instance, if this was on 2.4 gigahertz, and if you had 1 megabit per second enabled as a basic rate so that you'd support some of those devices, what you'd end up seeing is those beacons actually going out at 1 megabit per second, which is consuming a huge amount of your air utilization. So that's definitely something that, if they're not in use, then you want to say, hey, get rid of them. It's going to improve your life experience, your Wi-Fi experience. So it definitely is something that you want to get rid of if you're not using them.
Quick comment here from Anders. He says, you don't do 40 megahertz on 2.4, period.
I agree.
Yeah, that's one of those areas, I think, Anders, that there really is an absolute answer. Don't do it.
Yeah, I believe that the Wi-Fi Alliance kind of like puts that out as the, don't do it. But, vendors, they're always looking for something that they could kind of like say. So you end up seeing that some vendors do support it. I definitely agree with Anders. Don't do it. You're causing yourself some headaches there.
Chalky has a question for you, Dave. You have talked about high channel utilization in 2.4 gigahertz. What are the differences in 5 gigahertz?
Sure. That's a really good question. That there are a number of things in 5 gigahertz which you end up having to take a look at, which would cause your channel utilization to go up. There's typically what you end up seeing is that 2.4 is much higher than 5 gigahertz, and there's a number of reasons for that. And so one of them has to do with when Jim was talking about having a number of, too many access points, that there's also, just with a single access point, that you're able to receive the signal. And there's another point at which which is lower, which will make you to hold off on your transmission. So even though that an access point you're not able to receive its transmissions, it's going to be, you're going to view it as noise. And so therefore that's going to cause you to have higher channel utilization. With 2.4 being lower than the 5 gigahertz, just the way that the RF works, is that's going to make it so that 2.4 is going to be able to go much further. So that's going to add to that the channel utilization kind of going up. So that's just one of the RF characteristics of it. Another one is that we're talking about the low data rates. That 2.4 does go down all the way down to 1 megabit per second, whereas on 5 gigahertz, that the lowest data rate is 6 megabits per second. So just from that standpoint alone, if you just say, hey, I'm going to open up the box, I'm going to allow that these low data rates, that the 2.4 is going to have it so that it's going to be running at these lower data rates, and with the beacons, you're going to be eating up this the channel utilization for a greater period of time. And that's just strict overhead, and that's not your data that's kind of going through. So there's a number of reasons why that 2.4 is going to be bigger. 5 gigahertz. Now I'm going to talk about 5 gigahertz and then relationship to 6 gigahertz. That's one of the things that you have in 5 gigahertz is these protection mechanisms. That's because 5 gigahertz, there's, you've got 802.11a, there's 802.11n, there's AC, and then there's AX. Even when you introduce the AX, if it's in 5 gigahertz, it has to be able to allow that there's these protection mechanisms which add overhead, which are going to make the channel utilization go up because you're supporting these older devices. The promise of there's a lot of kind of benefits going to 6 gigahertz, and one of them is if you're running an AX and inside of 6 gigahertz, you don't need to worry about those protection mechanisms because 802.11a doesn't operate there. So that's one of those things that what you should see is when you go to 6 gigahertz, that channel utilization will be lower than on 5 gigahertz. And so that would be something else that you kind of end up seeing.
A comment here from Paul, kind of harkening back to a previous question, but he said, I recently worked on a refresh project in a London office and found 16 SSIDs broadcasting on a single WLAN. We gave some very strong advice to the customer, and I bet you did, Paul. I also bet they stopped at 16 because that's all that they were allowed to deploy. They would have gone further if they could, but the software prevented them. And that's the situation where that beacon overhead, that extra management traffic, will just create a significant increase in channel utilization on its own without any clients present. In the middle of the night, you could have a pretty large channel utilization in that environment without any clients even transmitting data back and forth with APs. So kind of a good transition, Dave, to a question from David, who said, what percentage channel utilization is high utilization? When should I be concerned? So any rules of thumb there, Dave?
Yeah, if you see that you're kind of getting up to 40% channel utilization, that's where it's like, that is an excellent question, because at the beginning where I was talking about, there's something where you might say, oh, you might see some issues, more major issues, and then, oh, the wireless network doesn't work. And so that the one that's showed the channel utilization, the kind of like the QBSS channel utilization, I believe it was like way up there, was up about 70, 80. That was an actual experience in an outdoor venue. And that is the extreme case of wireless doesn't work. That's, nothing's getting through. That really what you want to kind of do is see that you're kind of below that 40% mark. And if you start getting above that, that's where you start to see, oh, if you're at that 40% mark, you're starting to see some disconnects. Now, if you get a disconnect, what does the user see? If it's just a light disconnect, the user doesn't actually see anything. They might just see that, if you're doing a packet capture, you can say, oh, I can see that the client actually got disconnected and came right back up. And to the user, that might not see it all that much. What the user might start seeing is that their throughput is going down lower. So now that's going to be true of anything. The other thing I'd probably talk about with channel utilization, it's normal to see a very large channel utilization as a transmission is happening. So what do I mean by that? You know, that's what I mean is, say there's two people on the same access point, and one client is doing a file download. During the file download, that is normal to see that the channel utilization going way up. And so really what we're interested in is an average of that channel utilization. You know, what does that average sort of look like? And so that's where we end up when we're showing channel utilization. You can kind of dig into it very narrow, or you want to see an average. Really what you want to do is that average number to be below that 40%, not the peak, because a peak, yes, that's going to be normal for it to jump up like that.
Yeah, the average is really important, because if you take the extreme case, like moment by moment, well, when a client's transmitting, during that transmission, the channel utilization is 100%, and then when nothing is transmitting, it's 0%, right? So you really want to know what it looks like over some period of time.
Right.
And I also add, with 802.11 and the contention mechanisms that it uses, and the space between frames where no one should be transmitting, you should see it sort of peak around 80% or so channel utilization from Wi-Fi. And then if you see channel utilization significantly above that, you're probably seeing, collisions or a source of non-Wi-Fi interference. You're seeing a really busy channel, and you're also seeing problems with contention where clients are not backing off and transmitting on top of each other for a variety of reasons, or some other protocol is transmitting in the same channel, or there's a non-Wi-Fi source of interference. You really don't ever want to see it, much above 80% over that period of time that we're sampling at.
Yeah, along the same lines that the NIST did some work when I was involved in. This had to do with smart energy. There used to be a big thing a while ago, and they were looking at modeling the different technologies, how that they would respond. And they actually took a look, and they did some excellent work in this area as far as the how that as channel utilization, as the traffic goes up, how does how do things perform? And it's actually, once traffic starts to get so large that your experience you start to saturate and things start to fall apart. And that's what you really want to try to avoid, is that, the things starting to fall apart scenario.
Yeah. So it's that 40% threshold is where now you start noticing performance issues. Definitely voice and real-time applications will start to suffer. And 80% is kind of like where it's almost unusable. So stay out of that range if you can. Question here from Bruce. Dave, he says, how does SevenSignal measure channel utilization, and how is channel utilization measured by the AP?
That's I love this question, because I usually start off with new customers and describing some of this, because we do focus a very lot on it at SevenSignal. That's what you would end up seeing with SevenSignal is there's something we call the QBSS channel utilization. And this is what the access point is advertising as the channel utilization. The things that go into that calculation this is standardized, within IEEE, that it's going to measure that the transmission of packets. It will also include time that there is energy detect, which is going to hold off transmissions. So, for instance, if you had a constant transmitter on, it's going to see that constant transmitter on, and it's going to calculate, if it was constant, it would say, oh, you got 100% channel utilization because of that. If it's something like also that you have a neighboring access point, for instance, in an office, that the neighboring access point, maybe I can't receive the transmissions, But actually, as I was talking about before, you are receiving that signal. So it's bringing the noise floor up to the point where it's going to hold off your transmissions. That is also then included in that calculation. So you're going to see that that number is higher, and that's compared to when SevenSignal does a calculation. When SevenSignal is doing a calculation, what we end up doing is calculating from the sensor itself. We'll go off and say, okay, we're going to just listen to the traffic and receive the traffic, and then calculate what the channel utilization is based off of valid 802.11 traffic that comes in. At the very end of the packet, there's a CRC that says, okay, that we actually received that. And so therefore, what you should typically end up seeing is that when the sensor is calculating the channel utilization, there's some type of relationship to the QBSS channel utilization. And that's keeping in mind because it's the traffic by the eye that's able to see, or be able to receive, that is actually 802.11 traffic. Why is that useful? This could tell you about whether you're having some type of noise. And then also that, we calculate, for instance, we were talking about beacons and probe requests and probe responses. We could just say, okay, let's calculate, because we're doing the calculation on valid traffic that we receive, we now could then say, okay, this is the amount of traffic of 802.11 traffic is with the beacons. This portion is with the probe responses. And so therefore that is kind of able to give us guidance and yourself, if you're a SevenSignal user, as to say, oh, the types of things, this is what's causing my high channel utilization. This is what I need to do. Once you know that, coming up with solutions to address it is easier to understand.
All right, thanks, Dave. And Kelsey, maybe one more question here. Raimondo says, don't controllers resolve the problem of too many APs in an open area by trimming the cell size?
They do, but you do still run into, as we're discussing, that the neighboring APs, if you're in an office environment, and so say, for instance, that the cell size becomes smaller, that the neighboring access point, it's still transmitting, and when it's transmitting, that you're not able to receive it because the transmit power is lower, but you're still being impacted by the noise floor going up. And so therefore, that even though you're not able to receive it, you're not going to transmit. So that channel utilization is still kind of going up. That'd be one of the things that does relate to the things as far as coming up with a channel plan. Like for instance, do you do a manual channel plan, or do you allow something like RM or ARM to do that for you? Then you have to take a look at it. How good of a job does it actually do?
Yeah, and just a little editorial, I guess, on my part. I think, in those really difficult, challenging RF environments where you have a lot of APs on the same in the same space, that's really where those auto RF algorithms struggle. And so I think a lot of the engineers working in the large public venue area really prefer to do static channel plans, partly because the complexity of the problem is so great. It's hard for those algorithms to handle it, but also because the areas are so dynamic. An algorithm may have come to some stability in its design in an empty arena with APs under seats, for example. And then you fill that arena with 100,000 people, and maybe one day we'll be able to do that again. But suddenly the RF environment is totally different, and the algorithm has to change channel assignments and transmit power and handle that in the moment, which is disruptive. Whereas a static plan, could account for that in advance. So there are things controllers can do, and the algorithms that they use to help, but sometimes it's just best to do a proper, careful static design and implement that.
Yeah, if I
That's
could
more of
add.
an opinion on my part, but just thought I'd share.
Well, I was going to add on to that as well. I'm totally agreeing with you, Jim. And now if you think about those things, like in those types of venues, like an arena, the added complexity is that typically that they have like directional antennas. So now you think about it, it's like, oh, they're doing their measurement. They're saying, does this access point next to it hear the transmissions to the next one? And the answer might be no, because it's up in the ceiling and it's got this directional antenna. But now what do the users see that are down that? It's like, well, so they're end up, saying, well, we could turn the transmit power up because we don't hear it. But to the users that are down on the ground, because there's these intentions, now that because they might be up very high, that they will be able to hear each other. So there are some limitations just from the standpoint of how those algorithms work, that in these types of venues like that, it can be problematic.
Yeah, for sure. I think that about wraps it up.
All right. Really great questions coming through today. We appreciate hearing from all of you. So thank you to all of you for joining us today, for giving us some time out of your workday to really dive into this topic. We love connecting with you all every single week to learn more about these topics, and I really appreciate it. So a huge thank you also to Jim and Dave for leading us today. Thank you guys so much.
Thanks, Dave. Thanks, Kelsey.
No, thank
Thanks,
you.
everyone. Hope to see you next week. Have a great rest of your day.